Hello once again, this is Curtis with Pragmatic Agile, and I'm here to help you, that's right, reduce the suck. I'll explain what that means in another episode later on. In the meantime, in the previous video, we went into a deep dive on velocity and some concepts that I think are overlooked a lot of times in Agile training, Scrum training, and this time what I'm going to do is go into some flow metrics with the idea of helping you to understand these metrics, which I believe augment Scrum metrics extremely well. Or if you're going to go run a Kanban team, you have to know these metrics anyway. So stick with me. We'll be right back. So let's talk a little bit about what are flow metrics. Flow metrics are the metrics that are associated with what we call Kanban, but beyond that, Lean uses them. They're used in all sorts of businesses to determine how long it takes for value to flow through our value stream. You'll hear me talk about value streams later on, especially with regards to your board and how you set those up. There are a few metrics we're going to start with that you have to understand. The first one is going to be lead time. Lead time is from the time an order is placed to the time it is delivered, the time it's done. Think about, for example, if you order something on Amazon or any online site, from the moment you've placed that order until the time where it's delivered, that is your lead time. All right? I place the order, I get the order. Lead time. In software, it's generally going to be from the time that a request gets made and it's approved. Okay, we can cut it off there because think about, I can make a lot of requests and a lot of them will get rejected. So those, we don't count those because they were invalidated. So only from the moment a valid request is made that's going to get worked on, that's where I start clock for lead time. Cycle time is a subset of that time. As you'll see over here, your order was placed over here. Hey, we want this new feature developed. Well, guess what? It's going to sit there for quite a while. First of all, it's going to get some analysis done. Some other work might be done on it, but it won't actually get started by the team until much later. So the time that the team picks it up and begins to work on it, it's actually in progress. That's your cycle time. Within that cycle time, there could be multiple statuses. For example, there could be some analysis that's being done or design is being done on that. Development, you're testing, you're getting approval. Maybe you're doing some other additional testing in another environment. You could create a value stream of multiple statuses that visualizes how work gets done in your team. Or it could be as simple as ready, doing, done. I have my preference, and we'll talk about that in a minute, but that's what we're talking about. So cycle time is really when the team picks it up and begins to work on it. Now, throughput is a count of issues that are completed during a time box. It's a simple count of issues. And you'll notice that in this diagram here, all right, the order was placed, it waited for a while until we could get to it. Now we're working on it. And let's call this an iteration. Okay, it's a week, 2 week, month. Doesn't matter. In Kanban, they don't have rigid iterations. They have what I call soft iterations. These are time boxes that are on regular cadence. So you measure, hey, how did we do these this week? Or how did we do these 2 weeks? Or let's measure what we did this month. And it's up to the team really to determine how frequently do they want to measure that cycle. You can call that an iteration. You can call it a time box. Just don't call it a sprint, because a sprint is a Scrum time box. Okay? Iteration or time box is fine. In this one, for example, they got 5 issues done. You notice that they're all very similarly sized. Size is going to mean something in this. Okay? And the next one, they got 6 done. And then the next one, they got 7 done. So their throughput per time box is first they did 5, then they did 6, and then they did 7. So if you wanted to say, well, what's your average? 6 is going to be our average throughput per iteration. Now you'll notice here that it's a simple count of issues completed during any time box or any iteration. Kanban teams don't they don't have to predict and commit to how many they're going to get done. They just turn and grab, when they're ready to work, they grab the next item that's ready. They work it, it gets done. They grab the next one and they work it. That's why it's called a pull system. It's not being pushed by the product owner or the stakeholders. They just pull. The thing is that the product owner and the stakeholders will have to replenish the backlog on a regular basis. So iteration length is not rigidly enforced. It's fluid. The team can measure iteration length as they choose. 1 week, 2 week, month, doesn't matter. Tasks or issues are typically not estimated and sized in Kanban. And the reason for this is that they attempt to right-size the issues up front. They do want them to be fairly small, but they want to also make sure that they're right-sized. That's not a universal, and not all teams do it well. But you'll see in a minute, I'm going to give you an example of something that'll help clarify that. So release estimation can be done, for example, if you have, let's say you do 6 issues per iteration every 2 weeks, and you have 60 issues in a project. 60 divided by 6 is 10. So you could say, well, it's probably 10 of our iterations, whether it's 1 week, 2 weeks, or a month, whatever. That's how long it would take. So that's generally how they could calculate how long it'll take them to get that done. Assuming that they can devote 100% of their time, that's 6 issues at a time, and they're not going to get distracted by other projects. Now compare throughput then to velocity. You'll remember that throughput is a simple count of issues. Velocity is the sum of points completed, but what's more, it's the observed average of points completed. So for example, over here you have, in this sprint, you had 30 points that you completed. In the next sprint, you had 32 points completed, and the next one you had 34. So what does that average out to be? 32. On average, we complete 32 points worth of work every sprint. So if I have 320 points of work in a project, and I do 32 per sprint, you can calculate that it's probably going to take you roughly 10 sprints. Give it some buffer, maybe 12 sprints, and that's how you would estimate it. Now, you'll notice that I'm representing the difference in size here. What does that mean? Well, here's a 1-point story, and a 3-point, and a 5-point, and an 8, and a 13. These are representing the level of effort that they have to go through to get each one of those stories done. And in other words, not all the stories are the same size. It's not the same task over and over and over again for just somebody else. Okay, it's not the repetitive, simple task. Scrum generally implies, by its nature, that there's some level of complexity and exploration in the process. And so they will size their stories as a way of saying, how many of these things can we get done in this time box? And it drives a conversation. We use it to forecast how much we can get done in a sprint. So this way, there is a level of predictability for the team, and you can measure, is our system stable and predictable? Are we consistently delivering valuable software every sprint, every 2 weeks generally, all right? So knowing a team's velocity allows you to estimate a release. As I said, if you had 320 points in a release and you do 32 points per sprint, then you know it's going to take you about 10 sprints to get that release done. And I'm simplifying things. I know if there's any smarty pants out there going, there's more to it than that. That's fine. I'm trying to keep it simple. Here's an example of a Kanban flow. And it's the most commonly known one that you can think of, Starbucks. Think about it. Starbucks is a Kanban flow. You get into a queue, you wait to your turn, you place the order, you pay, they hand off the order. What is the card? What's the Kanban card? It's the cup. They write on there, okay, hot coffee, macchiato, whatever it is, frappuccino, and they hand it off. All right. Frappuccino, coffee, macchiato, another frappuccino, another iced coffee. And in a time box, I was able to do 5 of these items. That would be my throughput. So the coffee throughput would be 5. Cycle time per coffee, in this case, is 1 minute. It only takes us a minute. And they're trying to train people to be able to finish 1 coffee per minute or less, probably. And so the lead time for the order is from the time I place the order to the time I get it. In this case, it was 5 coffees together, 1 minute each. It took me 5 minutes to get all 5 of them. Now you'll notice that the size of the level of effort that it takes to do each one of those is relatively the same. A hot coffee, hot tea, macchiato, it's all roughly the same. There's a little deviation, but not much. There's very little variability in the system. And even when they added food to the Starbucks line, they prepackaged it to keep the time about the same. So you could just grab a package, warm it up, hand it off. They don't introduce any type of food item that would increase the variability. So imagine now if it was like a Scrum situation where you not only have your coffee, which is your 1, and a macchiato, which is maybe a 2, And then suppose they had to go and make other food. So a steak might be a 5 or an 8, and a lobster dinner could be a 5 or an 8, or maybe a 13, depending on, what you have to do to it. If you had to make a salad from scratch, that might be a 5. Unless it's prepackaged, then it's a 1 or a 2. So it really depends on how you arrange things in the beginning. But you can see that you could end up with this wide variability. Most of our tasks are 1s or 2s, but some of them could be 8s or 13s. And some of them, somebody could come in and order a brand new thing that's not even on the menu. And therefore, we'd have no idea how long it's going to take. So that would be maybe a 20 or a 30. It's off the charts big. We don't even know if we can get it done. What is your manager going to do? Your manager of the restaurant's going to say, we don't provide food that's not on the menu. We limit things to the menu so that we don't end up off the charts and messing up our delivery. Software doesn't really have that choice, do they? Right? If the executives come to you and say, I want this thing, and you're like, I've never made anything like this, you're in all new territory, aren't you? And that's where Scrum is really, really strong. So work in progress is another concept to understand. It's not really a metric, but you have to really understand it anyway. So one thing you're looking at right now, this is a very, very simple Kanban board. Could be a Scrum board. Okay. By the way, Scrum boards are not Kanban boards. Scrum boards are visibility boards. Kanban is Kanban. And in this case, you have only 3 columns. You have a backlog, in progress, and done. So cycle time is measured with how long things are in this column right here. What's going on inside of in progress? Can you tell me? Can you look? No, you can't, right? You can't see that because you only have one status. And so if they're doing design, development, testing, migrating to another environment, doing regression testing, doing performance testing, doing load testing, then preparing for a release, then pushing out, all of those activities are not shown in this kind of a board. Some coaches and Scrum Masters and Kanban Flow, they like this simplicity. I find it troublesome, and I'll tell you why. Now, back to the WIP. So WIP stands for work in progress. And you can see you have 3 items right now that are in progress. So what they might do is the team will say, we're going to limit how much we have in progress. We have only 3 developers on this team, let's say. So ideally, we shouldn't have more than 3 items in progress. Some teams will say, let's get down to 2 items in progress. We should be working together on things, so we really shouldn't have more than 2. Again, really oversimplifying this, but you're trying to reduce the number of items in progress for a couple of reasons. One, to reduce multitasking and context switching, because that's wasteful. When you're constantly changing between jobs that you're working on, you lose time, you lose efficiency, and it causes you longer time to get things done. That'll drive your cycle time up. I started A, then I switched to B. A's still sitting there waiting. It's in progress, but nothing's getting done. The difference between the wait time and the actual touch time, you can measure. Lean does that, and they call it tact time or touch time and waste. The other reason why you might want to limit your WIP is so that you can drive collaboration. Try and get people to work together on a single story. Now, let's talk about those boards. As I mentioned, that previous board only had 3 statuses. And I'm not real thrilled with that because if the team is new, they're just really getting into Agile, they're just learning how to collaborate, maybe there's impediments within the team. This limit of visibility doesn't really tell you where the bottlenecks are, what's happening. You can look right here and you say, well, something's not right, right? Look at this. Here you are, you're in progress, but you got 14 items in progress. Well, where's the bottleneck? Where's the issue? Why do you have 14 items in here? Let's say that they've just got a terrible, they're violating their WIP. Maybe they set it at 5, but for some reason we have 14. Or maybe the team is fairly large. Maybe there's 10 people on this team. And so they said, we can have a WIP limit of, 10 or 11. Okay, everybody should have one thing they're working on. Maybe that's the way they're thinking about it. I'm not saying that's advisable. I'm just saying that was the way they were thinking about it. Well, in this case, there's an emergency. So now they're up to 14 because they had some priority work. Maybe. I'm not sure that's the case. So I would look at this and want to know what's going on, but I can't tell because of the board. The way the board is designed doesn't give me any transparency. So let's get some transparency. So what if we designed the board so that it represented how we actually work? On this board, you'll notice you have your backlog. This is where items are getting ready for the team and the team is able to pull from it. Currently, there's nothing in that backlog. So do you think that might be a sign that somebody is getting behind on the replenishment of the backlog? It's something to look at. But there should be a few things sitting here. In progress is your first status. Notice your cycle time is saying, hey, it starts from here and it gets over here to done. This is your first status, and you've got 4 items in here. Is that too much? I'm not sure yet. Now, I add another column here, which is I'm waiting for test. I want to see if things stack up in waiting for test. And in this case, look, I've got 4 things in waiting for test. And I have 1 thing that's actually being tested. So if I were to see this, what conclusions could I draw? Well, maybe we should stop developing, pivot over, and start testing. This might indicate a couple of things, right? This could be a company where you have dedicated developers and 2 or 3 dedicated testers, and developers won't test. And they say, hey, developers don't test because we're paid more and we're specialists, we develop. Testers need to test, that's their problem. So they're silos and they're not collaborating. By seeing it on the board here, I can begin to tell what's actually going on and start asking, well, why do we continue to develop? Why don't we finish these first? Now look over here. Now you've got something in testing and you drop it over here for approval. So you've got a waiting for approval, and then over here it's getting approved. So maybe over here the product owner is taking a look and reviewing it and making sure that it does what they thought it should be doing. But again, it's stacking up over here. So the developers are just crushing the development, it looks like. But once it gets to the validation process, both testing and approval, we begin to see some bottlenecks, and we need to look at how we improve that. Now, once it gets through approval, what does it do? It gets to ready to deploy. It's not yet deployed. When it's deployed, it's done. That's our definition of done on this team. When it gets deployed, it's done. But look what's happening. Look at it all stacking up here. This is an interesting pattern. So now we have a bottleneck and waiting for test. We have a bottleneck, we're waiting for approval, and we're apparently doing really big batches before we get something to deploy. This is not unusual. When I came into coach at a bank, a small bank, I actually walked into a team where they said that they were Kanban, and I saw 42 items waiting for test. 42 items waiting for test. About 7 things were in progress and development. 42 items were waiting for test. And then there was, 60 or more that were waiting for deployment. And so I asked what in the world was going on. And I found out they didn't have any CI/CD, no DevOps concept. All right. They deployed once every 90 days. So this is how they batched it all up. And then every 90 days they deployed it. They had something like 7 developers to 2 or 3 testers. Okay. Completely out of balance on develop and test. Plus you had one tester who had some, let's just say there was a tester who wanted to thoroughly test absolutely everything because she was terrified that any defects would get out into production. That's a good thing in a way. But it also got me to question, well, what about your automation tests? Why are you so afraid of that? We don't have automation tests. We don't have automated unit tests. So I have to thoroughly manually test, and this is what's driving this behavior. All right. Now compare that to this. You would not have that visibility. You wouldn't know what questions to ask. The transparency is a good thing. And I've put a little diamond on these because these columns right here, the pink ones, are waiting columns. That's waste. Remember I said that in Lean, we look at tact time, the time that we're actually touching it and adding value, compared to the time something's sitting and it's waiting. Waiting is one of the 8 wastes of Lean. So this visibility gives me the ability to look at where we have some inefficiencies. There's some charts you need to understand that will help you. You can use these with Scrum teams. They're not just Kanban. And in Jira, for example, these exist. You can use them with your Scrum team. I think Rally, you can only use them with Kanban teams, which is unfortunate. The first one's going to be the control chart. And I want you to take a look at what you're seeing here. On the Y-axis here, you have a count of days. This is how many days it took. On the X-axis, you actually have the dates that are passing. All right. So what this is going to say is the elapsed time for each one of these issues. Here is an issue right here. And its elapsed time before it got completed was a little more than 1 day. This is a cluster of issues. You see how it's solid green? And that its time was less than 1 day, a few hours, it looks like. The red line is the average cycle time for the time period selected. What is the time period selected? Well, if you go down here, this person has run this for the last 2 weeks. So today is up here sometime, and it went back to 2 weeks, and it collected all the data and displayed it like this. All right. So now the rolling average cycle time takes for this for this issue, it looks at how long it took for this to get done. And then I think it looks at the time, the completion time, the duration time for the last 4 issues and the 4 after those. And it creates an average. And that's where this ends up right here. You go over here to this one, same thing. It takes this item right here and these and averages them out. And you end up with this. And then you have this, look at this one way up here. This issue took 6 days. So that's how you get this rolling average of cycle time. And this is really wonderful to look and say, do we have any trend? For example, here we were less than 1 day. And then boom, we started a trend where we increased our cycle time. It's really not a bad thing if you go from 1 day to 3 days. But can you imagine if this trend went up to 13 or 20 days? That would be an unfortunate series of events, right? So we'd have to look at that. The control chart also looks at, here's what columns are we going to select. So in this one, it looks really good, doesn't it? It looks like under a day and a half, your average cycle time. But what are we looking at? We're looking at in progress. So only the time that it's in progress is a day and a half. Now, if that's your entire flow, if that's everything that you have on your board, that's pretty dang good, isn't it? But if that doesn't include you're waiting for test and you're waiting for approval and waiting for deploy and deploy, right? If it doesn't include all of that, then it's a very narrow window into what's happening. You can at least say that probably my developers are doing a good job. They're developing stuff quickly. The rest of the cycle is not going very well, but we're not sure yet. Here's another control chart. You can see that your average is about 16 days, it looks like. You can see the rolling average has been going up and down, but it's hovering around in there. It doesn't look too bad. You see a fairly stable, look at all these issues and issue clusters that are being delivered fairly continuously. This time frame was for the past month. Okay. And it includes these columns: developing, design, test. Okay. So there's a whole bunch of things in here. You'd have to click on that arrow to see everything that you've included, but you can include and exclude columns if you want to drill down a little bit more. This tells me that on average, it's taking them, let's see what it says here. 1 week, 1 day, 7 hours average. All right, that makes sense. So that's a little bit long to get a development story done. If this is features, that would be one thing. But if these are user stories and it's taking me greater than, what is that, 6 days, average, 6 days. And you have some up here. Look at these items, guys. Here's a 60 days. So you've got issues up here that are taking 60 days or more, 100 days to complete. Something ain't right there. That's where you really want to drill down. What in the world? Now, here's another one. Control chart number 3. 40-day average. Not looking good. But if I look down here, they've included to do. So this is just in the last week. I don't know why you would include to do. You're not working on it in to do. So that's sort of like measuring how long things are sitting in your backlog. Maybe you want to see if things are aging over there. Okay, perhaps. I noticed that you've got a terrible cycle time. 40-day cycle time is horrible. This is why you can imagine using this with a Scrum team and you have your 2-week iteration, but if you look at your cycle time in addition to your velocity and your predictability, and you can see that most of your stories are getting done in just a few days, that would make sense if you've got 80 or 90% accuracy. But if you have 50% accuracy and you find out that your average cycle time is 10 days, now you know why you're not completing everything, because most of your stories are taking a lot longer than you have time for. So then if you combine that with average story size, all right, I'm going to go out and I look at how many story points I've got. If most of my stories are 8s and it's taking me 8 or 10 days to get them done, that makes sense. But now we need to vertically slice. But if I look out there and I say, most of my stories are 2s and 3s, but it's taking them on average 8 or 9 days to complete, then that means our story sizing effort isn't any good. So something's wrong there, because what it's telling you is the team is forgetting things that they have to do. They're getting sloppy. Maybe they're generating a lot of defects. Now you need to drill down and figure out what's going on. So the combination of your predictability in Scrum, your cycle time that you can see over here on your control chart, your average story size, you can begin to drill down and provide some data to your team and say, look, our average story size is just 2, but it takes us on average 10 days to complete it. Why is that? What are we forgetting? Once you solve that problem, then you can begin to say, all right, Let's see if our predictability gets better, and I'll bet you it will. Now, there's another chart we're going to talk about, which is the Cumulative Flow Diagram. This is a way of seeing the way that work is flowing through the board, all right, by status and where things are getting stuck. Okay, so again, here's your count of tasks. This is a count of tasks, and these are the days that you're monitoring. So lead time is from wherever the request came in until the time it got done. You see this right here? Throughput is the count of issues as they get done. They're clicking into the throughput. So you only got a little bit of work done in 2 months. That ain't good. The WIP tells you, look how many items you have in progress here. This is telling you what you've got going on here. You've got about 20 issues in progress at this point. You notice the statuses up here? To do, analysis, work, verify, done. So the moment it goes into analysis, that's where they're going to start counting their cycle time. You could refine it, say, I just want to see what the cycle time is for the developers. So you could start your cycle time at work, all right? But in this case, they're going to start it at analysis. Here's another CFD. Notice that their flow, their value stream, all right, so it starts with conceptualization, and then they do a review, follow-up in progress, ready to review, peer review, waiting on link, ready for delivery, done. And you can see how work is stacking up over time. You can see your cycle time from here to here is showing you about 7 days. Right here, you have 10 tasks in progress. Now you can begin to identify bottlenecks through where you start seeing where things are not moving along. For example, look at this waiting on link. There's a lot of items that are sitting here right now waiting on a link. Once you got that link, everything started to flow again, and you slowly began to get ready for delivery and started to deliver. Once again, look at this. Looks like they got stuck waiting on a link. So you can begin to identify where there's a bottleneck in your flow by where these bands start to get thick. All right, let's see if there's another one here. This is a rally CFD. Now you notice that this doesn't do count of issues, this counts in points. So I've got 32 points at the start of the sprint. Right about here, I had about 8 points in progress on day 1. By day 2, that opens up to be about 12 points in progress. But you see that things start to go to accepted on day 1. They were already getting a few things done, even on day 1. Day 2, here they go to completed. That's probably you're waiting for approval. It's done. It's finished for us, but you need to get a product owner approval. Then they get it. And you can see that this band of in progress stays relatively controlled all the way through up to the end of the iteration. So this is a cumulative flow diagram on a Scrum team. And you'll notice that they started off with a certain number of points, but by day 4, they realized, hey, we're making progress. Let's bring in another 1 or 2 point story. And a few days later, they brought in a couple more, and they brought in a couple more until by the end, they noticed that they were getting way ahead of things and they could bring that in and complete it. And they completed 100% of everything that they brought into the sprint. So that's not a bad thing. They left a little bit of slack, and then when they had time, they began to work on those new things. I do see a little bit of, looks like a little bottleneck here and completed toward the end of the sprint. You see how it got thick? So what I would wonder is, did something happen with their approval process with the product owner? In the end, the product owner came in and had a very busy last day, and they got everything approved. This could be worrisome if sprint over sprint, we have a lot of stuff that's getting hung up on the last day and then not getting approved. That could be an issue. If you're a Scrum Master, you really should study flow metrics, work with whatever ALM you've got, see if you can use those with your team. Combine the flow metrics with your Scrum metrics and start to learn what it's telling you, what's actually going on in your team. If you have any questions or want some additional information, put a question in the comments below. Like and subscribe. Thank you very much. Have a great day.